This is a video on procedure parameters and pointers for the language C. To review, the definition for procedure is a short, named group of commands designed to complete a specific task. There are two types of procedures, subroutines and functions. Subroutines do work, and functions do work, but they also return a single value. The generic syntax for procedure in C is the return data type, followed by the procedure name, then one or more optional parameters in parentheses, and then inside curly braces you have one or more commands. The return data type can be any valid C data type. Use void for the data type to indicate that the procedure is a subroutine and that it does not return a result. So for example, here we have void display instructions, and that is an example of a procedure that does work and does not return a value. Use any other data type to indicate the procedure is a function. If it is a function, it must return a result. Use the return keyword to return a value. For example, float get pi means it must return a float compatible value. So we use the return keyword and the value 3.14159. Notice F, so that it does not default to a double float. It defaults to a single float by default. Any number with a decimal in C automatically defaults to a size of double. Now, execution of the commands in the procedure stops as soon as a return command is encountered. So for example, if I have float get by and then the command return and then a value, the execution of the procedure stops there. This print message will never ever be displayed. After the procedure name, inside the parentheses, you can have one or more parameters. Parameters are values or variables passed into the procedure by the calling procedure. The syntax for parameters is data type space variable name. For example, we have is even and then int value. It passes in one integer variable or parameter, sometimes called an argument, and it is named int value. Now, multiple parameters can be passed in, and if you do, they are separated by a comma. So here we're having a function int add two values that presumably takes two values, value 1 and value 2, adds them together and returns the total. When naming procedure parameters, also known as arguments, always follow the regular variable coding standards. That's proper case, prefixes, descriptive names, no abbreviations. It's very important. Readability is king. Here's an example of how to pass values into a function. Now, I don't have room for the comment blocks, but you should always have those in your code. Now, remember there are three steps to making and using procedures in C. The first one is you have to have the definition. So down here we have the defined procedure. So int, it's a function, and it's going to return an integer value. Add two values tells us what the function's going to do. Well, it's going to add two values together. Those values are int value 1, comma int value 2. It's going to add those up and return it. Now, after we define it, we have to tell the compiler what to expect. We are bringing company home for dinner on Friday, and we need to make some reservations. So, how do we do that? We take the first line of the definition and copy it and paste it up top and throw a semicolon at the end. And that is how you do a prototype declaration. And after you define it, then you can go ahead and call it. Now notice here I'm passing in two hard-coded values, 5 and 10. Those will get passed in the order that they are specified. So the first value goes into the first variable and the second value goes into the third variable. If I have a third one, it would go into the third parameter. It'll add those two together, return them. Using the assignment operator, we can assign the return value out of the function into a variable, and then we can go ahead and print that out. Pretty cool, huh? Now we can use variables instead of hard-coded values, or a mix of each in the call. So on the previous slide I had 5 and 10 hard-coded in, but on this slide I have 5 hard-coded and a variable. Now I can use all values, hard-coded values, I can use all variables, or again a mix. So in this case I've declared int value 2, set it equal to 10. It's going to pass both of those in. 5 plus 10 is 15, and it should print out 15 when it runs. The names of the variables in the calling procedure, that's up here, right here, do not have to match the names in the called procedure. That's down here. Now notice I have the horrible variable name A. That's abbreviation, not descriptive. No prefixes. Yeah, it's horrible. That's for demonstration purposes only, or never to do that. So everybody raise your right hand. I promise I will never make bad variable names. Okay, y'all promised. And then I'm returning it and storing it in a value X. Oh, that's horrible. I had difficulty just writing this. That's how bad it was. Anyways, so down here in the calling procedure, int value 1, int value 2, it doesn't care about the names or whatever it was in the calling procedure. So in the call down here, we can have whatever we want. Now notice we have the return variable total. That gets assigned X. So now the names don't have to match, but most of the time they should. We want to have good practice, good coding standards, promote readability and all that. This is just an exaggerated example to show you that although they should match, they do not have to. Often you'll see code examples where the prototype, remember that's the declaration to tell the compiler what to expect, has just the parameter data type and no name. For example, int, int. The parameter names have been removed. Now, a lot of C programmers like to do that. They are for writing the smallest, shortest possible variable names in the world. And from a single programmer's perspective, if it's code for them, that's fine. But from a manager's, company's perspective, that is not fine. So, while it is syntactically correct to do that, I don't want you to. And can you guess why? Readability, of course. Taking out the variable names makes it harder to read. So always make the prototype declaration the same as the first line of the code in your procedure definition with a semicolon. So remember, this is the declaration and this is the definition. Sometimes you'll see examples like this in the book or on the internet. Notice we got a prototype declaration, and inside void main they have a printf statement that's going to print out some number, an integer, and they put the function call in the printf. That's what I call fancy code. Fancy code is when you try to do too much on one line. If you write fancy code, guess what kind of bugs you're going to get? Yep, that's right, you're going to get fancy bugs that are harder to debug. It's best to stop bad habits like that before they start. So how do you fix the above fancy code? Well, you make a variable to store the result. For example, int total equals 0. That's our declaration. By the way, I always try to initialize my variables to 0 and not initialize them to some function value. I always try to, it's like the cast of characters of the play. At the top, they're all blank and empty, so I know what to expect, and then in the middle I have the actual coding logic. So I would not try to combine those two lines into one. Why? Because that is fancy. Here I'm declaring, here I'm assigning. They're two separate things. So I would make another variable and assign it. Now there are only two reasons not to make the variable int total. Can you guess what they are? Any ideas? Think about two reasons to use this first method instead of the second one. The two reasons are ignorance and apathy. Either programmers don't know any better, or worse, they don't care. Well, now you know better. So you can only claim apathy. Now, you always want to try to do one task per line. Whenever you call a function, try to always save the return value in a variable. Otherwise, you'll wind up with fancy, complicated code that's hard to read, maintain, debug, and support. And that will limit your advancement in the programming field because your code will be buggy and hard to read. Besides, if you do write fancy code, you'll have to debug it anyways. And when you go to debug it, because there's fancy code is more prone to errors, more complex, you'll have to break it up into multiple lines anyways. So you might as well break it up into pieces at the start. That's a great habit to get into, and it's one of the keys to my success. That and divide and conquer. They go hand in hand. There are a few homework problems coming up where you're going to have an excellent chance to experience what I'm talking about. Another bad programming habit with functions is the use of multiple return statements within a single procedure. So for example, get larger value, pass in two values, 1 and 2. If value 1 is greater than 2, then return value 1, else if value return value 2. No, 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 no. When you read a mystery novel, where do you expect to find out who done it? At the end, exactly. When you read the code for function, where do you expect to see the return result? At the end, exactly. So putting a return in the middle of the code is like leaving in the middle of a date. It's a bad thing to do and it's rude. Why? Because the code should read top to bottom just like a book. The variable should be at the top, the logic should be in the middle, and the return should be at the bottom. Don't break the pattern. Every time you break the pattern, you cause confusion and increase complexity. So to fix this code, we need to make a return variable, set it in the middle so we can return at the end. So here I make a variable called larger value. That's what it represents. It's named well. We assign that value. Notice this time I put in brackets, and I go ahead and return that at the end. Now that's much better. Remember, readability is the number one goal. If you can't read it, the code is worthless. So right now, a good percentage of you agree with me. You've seen bad coding examples on the internet, and you've probably tried to read the book. You find many of the examples confusing. I know I sure did, and from the feedback from students, I know many of them do. But there are some of you that definitely do not agree with me. Right now I can feel your intent gaze burning a hole in my forehead, right? You think these examples of bad coding habits are ridiculous. Often I get at least one program that wants to have a lightsaber battle with me. Alright, they want a challenge. They say, no, it's not important, it's not whatever. So I came up with a little test that I think demonstrates my points very well. We're going to have the $10 coding challenge. I'm going to show you just a few lines of VB.NET code. If you can tell me what it does in 5 minutes or less, I'll give you $10 of my own money. Now, since this material is being delivered online, I can't time everyone, so I won't be paying out the $10. But I assure you, when I teach this class online, I do time it, and if there is a winner, I do pay out. However, if you did figure out what this code does in 5 minutes or less online, email me what you think the solution is, and if you're right, I'll buy you a caffeinated beverage of your choice sometime. You come down to campus and I'll hook you up with a cup of coffee or a sweet, sweet Dr. Pepper from the vending machine, something like that. Now, in the 10 plus years I've been doing the $10 coding challenge, only one person has won, and he was a very special case. I like to use the expression overclocked. Yeah, he was definitely overclocked. So, you're going to need a clock, and I'm about to give you the challenge. So, are you ready? Get set, go. Here is the code. You've got 5 minutes. Now, I'm not going to make you suffer through the whole video. You should pause, time yourself, and when you're done, come back. No more than 5 minutes. Oh, by the way, I know it gets something from a string where there's a comma. I need it way more specific. Alright, time is up. Now, if we look at this code, there are only 8 executable lines. lpause, for, if, get item, exit, lpause, and do events. You don't really count the next, or the variable declarations. So now imagine many of you are completely and totally stumped and your head hurts. Well, so does mine after looking at that code. So to recap, did any of you figure out what it was? I know it gets a substring from inside a string, but I need you to be more specific. When you find out what the procedure actually does, you'll be amazed, but you're going to have to wait. You can email me if you think you have the solution, but remember, you get only 5 minutes to try to figure it out. Now that code was in a program in my last job, and when I saw it, I went cross-eyed. I had a tough time figuring out what it did, and then I realized that it was the perfect example of unreadable code. Now, why is it unreadable? Well, I'm going to let you tell me. Now, I want everyone to take out a piece of scrap paper or fire up Notepad. Then back up the video and look at the code. Write down at least 2 or 3 reasons why you think the code is unreadable, and then resume the video. Now, it's important that you make an attempt at this and write something down. I'm serious. I've been doing this a long, long time. You have to write something down. Don't just passively watch the video. Make your brain work. Okay, back up the video, write down your reasons, and then come back to this part. You should have a few reasons written down. Now, most students say the variables aren't named well, and I would agree. Byte X, byte Y, data, and byte TX are terrible names. Although they use prefixes some of the time, the variable names are not descriptive. The function name isn't descriptive either. Get item, get what item from where. There's no procedure comment block. There's no inline comments. The get item line in the middle is fancy code. It's doing way too much. Now, how would you like to be working on a project where all the code is like that, and it's tens of thousands of lines long? Welcome to my world. That was what my last job was like. If you write fancy code now on small projects, you will take those same fancy code writing habits with you to medium and large projects, and it will be a nightmare because you're setting yourself up for failure. So what's the moral of the story? Name things well, use comment blocks in line and at the top, do as little as reasonably possible per line. Now, don't go crazy with comments. Many students go from no comments to way too many. You want that happy medium, and you're going to get practice on all the homeworks. So, those few of you that disagreed with me about fancy code, yeah, I see you out there. I'm watching you. How many of you figured out what the code does, that code sample does in 5 minutes or less? I'm guessing not a single one of you did. So, I just proved my point. Fancy code is bad. Don't do it. Finally, here's one last example of true C code that I found out on the internet. Isn't that, it actually does something useful. I know what it does only because I looked it up. If you'd have asked me what that code did, I couldn't have told you. I mean, that to me is just, it's just crazy. Now, many C programmers are proud of writing code like that. They seem to take great joy in the complexity, lack of comments, and compactness of the code. Well, that code may satisfy the requirements of their ego, but it certainly does not satisfy the customer's requirements or the project manager's requirements. We as programmers are morally obligated to write code that can be read by someone else, because we may not be around to fix it later, upgrade, change it, or whatever. And why are we morally obligated? Because we got paid in good faith. As soon as we cashed that check, that's when we became morally obligated. Now, would you buy a car that needed the maintenance, all maintenance done by the dealer at $150 an hour? And you couldn't even change the oil by yourself? No, you wouldn't want to buy a car like that. So that's why cars are designed to be reasonably user-friendly, that you can, get an owner's manual and take care of them by yourself. Same with code. Anyone coming in behind you should be able to figure out what you're doing in a reasonable period of time. So back to procedures. In most languages, there are two ways to pass parameters to a procedure: by value and by reference. And if you've taken Visual Basic .NET 1, which is a prereq for this course, you should have known that. Now, passing by value sends a copy of the original variable. Any changes made in the called procedure are made to the copy. The original is unaffected. For example, I've got my main procedure. We now understand that main is a subroutine because of the void keyword, and it takes no parameters. And inside there I have int original. So I'm declaring a variable, and then I pass that by value. Oops, I'm missing my semicolons. I will add those in. I got the semicolons in, so I call pass by value, and I pass my variable, and then I print what it displays. Now, in my pass by value subroutine, this variable right here is a copy of the original. So the value inside it is a copy. Now I can change that copy. I can do whatever I want to it. But as soon as that procedure is done, that copy gets thrown away, and the original is unaffected. And when I print, I still get 0. In some programming languages, you can pass by reference. Passing by reference sends the original variable to the called procedure. Any changes made in the called procedure to that variable affect the original variable in the calling procedure. In C, all variables are passed by value. There is no pass by reference in C. So everybody say that with me. All variables are passed by value. However, you can pass a pointer to a variable. Pointers are data types, variable data types, that store the memory location, also known as the address, for variables. Let's use an Excel example to help illustrate the concept. Excel worksheets are composed of cells. You've probably all used Excel by now at least once or have some idea of how it works. Now, each cell in a worksheet has an address. For example, in this picture, the cell B2, so right here, B2, stores the value Y. The address is B2, and the value at that address is Y. The cell with address C3, so column C, row 3, currently has the focus. You can tell because of the shaded border. If I started to type, the cell C3 would fill up with whatever I typed. That's how you can have an address for each memory, or each variable, or each memory location. In most programming languages, you never ever have to worry about memory addresses. Why? Because it can be pretty complicated, so the other language take care of it for you. But that comes at a cost. You lose control when the language does it for you. Back when C was created, they had very little memory. They couldn't afford to waste a single byte. So they made the language C to let them program efficiently in a high-level language, but still have control. Let's talk about the declaration syntax for how to make a pointer. What you do is you say data type, asterisk, and space, and then a variable name, and then I always initialize my variables. You always want to initialize pointers to 0. Very important. Why? Because there is no default value for you. Now, the data type can be any valid C data type. For example, short, integer, long, double, or float. Now, notice the asterisk is after the data type. This is a data type modifier. It tells the computer that the variable is not a data type, but a pointer to that data type. Now, next comes the variable name. You should follow all the regular coding standards when naming variables. However, the prefix is modified slightly. Use a lowercase p plus the original data type prefix. For example, int asterisk is a data type of pointer to an integer. So we change our prefix to pint, which is a pointer to an integer. And that's not pint, it's pint. Now, that example declares a pointer to an integer. Now, some of my students ask, where should the asterisks go? Because they see different examples all across the internet or in their book. Some have it on the left, right next to the data type. Some have it in the middle, so you have your data type and then a space and then an asterisk and then a space and then your variable name, or it can be all the way on the right, so you have integer and then a space and then the asterisk and then the variable name immediately after that. So let's call those left, middle, and right. Now, all of the above are syntactically correct. Now, I was taught and often see the pointer on the right example. However, when I started teaching students about pointers, I realized the asterisk is a modifier of the data type. It doesn't modify the variable, it modifies the data type on the left. So, for the variable declaration, I started putting it on the left, this top example up here, and that's what I recommend you do, and I'm going to try to do that consistently throughout all the code and examples that I give you in this course. So once we have a pointer, how do we get the address of something to store inside of it? Well, to do that, we use the address operator. The ampersand is the address operator. So, first off, we declare a pointer to an integer. Then we declare an integer itself so we can get the address of it. Now, here is where you use the address operator. You put it in front of your variable, and that tells the compiler, hey, don't give me the contents of that variable. Get me the address of that variable, where it lives. So don't tell me what color carpeting is inside the house. Give me the street address of the house. So, for example, 123 Elm Street instead of blue shag carpeting. Now, once you get the address, you can use the assignment operator to assign that to a pointer type variable. Pretty cool, huh? And some of you are thinking, well, after I get the address of a variable, big deal. What can I do with it? Well, let's do this whole example over again. Declare a pointer to an integer, and in an integer, get the address of that integer, put it in our pointer, and then we can print out the address if we want. So, for example, printf, and then the address is, notice %p, that's for pointer, and I print the contents of the pointer variable, which is going to be the address of the variable. And notice these two lines are the same. They are functionally equivalent. Here I use the address of and print a pointer, and here I print the contents of the pointer. Pretty neat. After you have a pointer to a variable, you can dereference the pointer and access the contents at that address. To dereference a pointer, use the asterisk, which is the unary indirection operator. So we've got two lines here. The first one, we print the contents of the pointer variable, which is going to be the address. If I use the unary operator, I will dereference the pointer. Instead of printing the address, I will print the contents at that address. And I've got the wrong placeholder for an integer. Thankfully my prefixes saved me, so let me pause and fix that right now. There we go. It was a %s, which is wrong. It should have been a %d. So the first line again prints the address. The second line prints the contents at the address. So the unary operator, the unary indirection operator, is used to dereference a pointer and access or manipulate the contents at the address stored by the pointer. So the different uses of the asterisk can be a little confusing. Let's look at those uses one at a time. Now, an asterisk makes a data type a pointer to the data type when it's used in a variable declaration. So as we can see here, if I put the asterisk there, that modifies the data type and it changes from integer to an integer pointer. Now, an asterisk is the multiplication operator when it's used between two variables. So 5 times 10. That's a second use for it. And an asterisk is the indirection operator when used in front of a pointer. So here I have some variable int value, and I get the address of that, store it in my pointer, and then I want to print out the contents at that address. I say the contents at, notice the asterisk is in front of the pointer. That dereferences it, and it should print 50. Where did I get 50? Well, 5 times 10 was stored in there. So the purpose of an asterisk is context sensitive. It's part of your job to learn what it does where. Now, that's not an obstacle, that's an opportunity to make lots of money. Pointers are data type specific. You can store the addresses of only the declared data type inside one. For example, you can't do the following. Here I've got a pointer to a short. I have an integer variable, and I try to get the address of the integer variable and store it in my pointer to a short. So you can store only addresses to variables with the short data type in PSHT value. Trying to store the address of an integer variable like int value will cause an error, and that error is something like address of int asterisk can't be assigned to an entity of type short asterisk. Anyone feel dizzy or nauseous? That's all perfectly normal. I know I did the first time I learned about pointers, and I specifically remember getting crushed on a test in high school that was about pointers. Sad part is I thought I did well until I got it back, and it was not good. So why on earth would anyone want to make or use pointers? That's a really good question, and here are 3 reasons. The first one is it allows the programmer to emulate pass by reference. Now, believe it or not, all the other programming languages don't pass by reference, they emulate it with pointers. That's how it's done underneath the hood. So you've been enjoying pass by reference, something that doesn't really exist. It's all been handled with pointers without you having to worry about it. And so that's why we're kicking it up a notch and learning C. We are going to learn how to do that stuff on ourselves. Second good reason is dynamic memory allocation. Dynamic memory allocation is when you create variables while the program is running, as opposed to static memory allocation. Static memory allocation is when you declare variables at compile time. So probably in most of your classes, and this may be the only one that you vary from that, you make all your variables at runtime. At compile time. You don't do any extra variables at compile or at runtime. We're going to learn how to do that. And finally, the last issue is control. Using pointers gives you an incredible amount of control over data, and it allows you to very efficiently manipulate large amounts of that. So, for example, if you're doing like graphics programs or huge amounts of just statistical operations, stuff like that. Now, we're going to learn about how to emulate pass by reference next using pointers. We'll learn about dynamic memory allocation in a few weeks, but we won't get to the control part. We're going to do a little bit of that, but you're going to have to wait till you're on a job when you actually have massive amounts of data and the need to manipulate that quickly and a customer that's willing to pay for it. But we will get you well prepared when that challenge comes around. Let's see how pointers can help us to pass a variable by reference. That's a simulation. So I've got void pass integer by pointer. Notice my data type is not just an integer, but it's an int pointer, and I have the proper prefix and everything. That's my declaration. Inside main, I declare an integer variable, and I assign an initial value or initialize it to 0, and then I pass that by pointer. And so I put the ampersand, remember that is the unary address of operator, And instead of passing the variable, that passes the address of the variable. We come down here to pass the int by pointer function or subroutine, and inside I catch that address that was given to me. Then I use the indirection operator to dereference the pointer and access or modify the contents at that address. So let's say this variable lives at 123 Elm Street, and inside it has a value of blue shag carpeting. So the address is 123 Elm Street. The carpeting inside the house at that address is blue shag carpeting. So when I call pass by pointer, I don't pass the blue shag carpeting, I pass the address 123 Elm Street. The carpet company down here gets that address, 123 Elm Street. Once they get that address, they go inside, they dereference the pointer, so they go inside the house at address 123 Elm Street and change the blue shag carpeting to some, I don't know, vivid orange shag carpeting. So they're passing around street addresses, and then they use the asterisk to dereference or go inside the house at that address and change the contents. So that is how we can emulate passing by reference using pointers. Wow, I feel my brain getting bigger and stronger as the minutes go by. So I'm guessing pointers are probably new to every single one of you listening to this. They are challenging and confusing, but with practice you'll master their concept and their use by the end of the semester. I'll make sure you have plenty of homework assignments and quizzes utilizing pointers to help you learn and grow as a C programmer. It's going to hurt, but that's how you know you're growing. If it doesn't hurt, then it's easy and it's a waste of time. Woohoo! The summary. All variables are passed by value in C. No pass by reference. Pointers are variable data types that store the memory location or addresses of variables. The syntax for declaring a variable is data type asterisk, space variable name, and then always initialized to 0. Use the address of operator, ampersand, to get the address of a variable. Use the indirection operator, asterisk, to dereference a pointer and access or modify the contents at the address stored in the pointer. So every time I see the ampersand, I literally translate that in my mind to the address of, and every time I see the asterisk in front of a pointer, I say in my mind the contents at the address. So the contents at the address. And the reasons for making and using pointers is emulate pass by reference, dynamic memory allocation, control, and torturing of students in programming classes. Oh wait, did I say that? No, I'll have to edit that out. And that is the end of the video.